Okay, so welcome back. On Thursday last week, we would have looked at set difference, and we were doing a few questions in class. We looked at questions 8, 12, 15, and 17. I went on to speak about set difference, like A less B and B less A. One thing I didn't really explain is the commutative property. Basically, when you have addition and subtraction, and you would have done this in numbers in first year and at the start of second year, like 3 plus 4 is the same thing as 4 plus 3. So when you're adding sets A union B and B union A, when you put those two together, it's the same numbers. Same with the multiplication, 3 by 4 and 4 by 3 is the exact same answer. Okay, so again, the intersection of A and B is the same as the intersection of B and A. Okay, so it doesn't matter when you get the union or intersection, if you put A first or B first, it doesn't make any odds, it's the same numbers. But what's different is subtraction or division. If you have subtraction 6 minus 2, that's 4. It's not equal to 2 minus 6 because that's minus 4. So 4 is not equal to minus 4. So we can say that negative or subtraction difference is not commutative. And that goes on to set difference. So the subtraction rule is the same thing as A less B. So if you take away B from set A, you're left with A, C, E. But if you take B less A, so if you take away A, they're the letters F, G, and H. So set difference is not the same thing, but the intersection or union, no matter what way you say the set, it doesn't affect your answer. So that property is commutative. We're going to see associative there in a little while, but it's just saying that if you had union or intersection, it doesn't matter what way the letters are written, but set difference is not the same thing. If you have B less A or A less B, it's a completely different answer. And we'll see that when we start doing the questions 1 and 2 directly underneath. On Thursday, I had started doing question 1. I had drawn it out for you, but I hadn't actually finished off the solution for you. You were to do this in class. So this was question 1. I finished off on Thursday by actually drawing it out, but I never give you the answers on it, and I'm going to do those now. So I have part 1, part 2, part 3, and part 4. Now, when you are giving elements in a set, you have to give them in chain brackets. So all of these will be in chain brackets. So I'm just starting off the chain brackets for it. So it's saying A less B. So you're going to cancel out B and you're going to write all the numbers that are left in set A. And normally you try to do this from smallest to biggest. What I mean by that is 1 is the smallest number, then 2, then 4, then 5, then 7, and then 8. Okay, so that is A less B. Then we're going to do B less C. So we want what's in B, but you're going to take out C, so cover C, and the numbers are 3, 9, and 10. Next of all, you're looking for A less C. So you're going to cover C, and you're going to write whatever's in A, and that's 1, 3, 5, and 7. And finally, you're looking for C less A. So you're going to cover A, and you're going to write down everything that's in C. Now, there's nothing. That's the null set. So that can be written as empty brackets, empty chain brackets like that, or you can write it with a circle with a line going through it. Both of those things mean the null set. So that's question 1 done. And you can see from my answers part 3 and 4, this was A less C and this was C less A. Now, this is going on about the commutative property, that when you take away something and the letters are written this different other way around, that the answers are not the same. However, with union and that, it is the same. Question 2. And I'm just going to kind of bring it into the focus there for a second because my diagram is given to me. I don't have to draw it out, which is brilliant. There's 4 parts to it. So 1, 2, 3, and 4. First one, A less B. So I'm going to cover B and I'm going to write down whatever is left in A. That's A, C, and E. Then we're looking for B less A. Again, you cover A and you write down what's left in B. That's F, G, and H. Okay, and I was explaining that there a couple of moments ago. The union set, less A, so the universal set. So you're going to cover A, all of it, and you're going to write down everything else, and you're going to do it from smallest to biggest. F, G, H, I, and J. Okay, so that's what's left. Then it's the union set less the intersection of A and B. So the universal set taking away the intersection. A, C, E, F, G, H, I, J, and that's it. Okay, for class today, I'm going to get you to do questions 3 and 6. So 3 is this one here, you're just answering the questions based on it. And we're also going to look at question 6, but not yet. So that'll be your classwork there shortly. But I want to explain the intersection of 3 sets. So Venn diagrams involving 3 sets. And you're going to take out your notes copy now, and we're going to essentially, I'm going to talk you through this, but you're going to take it down in your copy also. So that diagram is on page 46. And in your copy, you're going to draw it out. Okay, so notes copy, and this is page 46. And your title for this is Venn diagrams involving 3 sets. So 3 sets are just the 3 circles A, B, and C. And I'm going to explain what all of these numbers mean. So this is region 1. This is region 2. Region 3 is all of this bit here. Region 4, region 5, region 6, region 7, and region 8. But I'm going to use a notation for people to see what the notation is involved in it. So we can see with the first one, region 1, it's where the 3 circles intersect. That's A intersection B intersection C. So it's where the 3 of them cross over. And you can write that underneath, intersection of all 3. Okay. Second one, it is this region inside here. So it kind of seems to be where A and C cross over, and you're taking out B. So you're just left with that little bit inside there. So A and C, it's the intersection of those 2 taking away B. So that's A intersection C, all of that together, less B. So it's the intersection of A and C together, taking away B. Less B from intersection of A and C. Next one, section 3. These are people that would just use 3 on its own, so it has no other intersection. So it seems to be C on its own less A and B. So A and B are out of the equation. So it is B less, C, apologies, that's C. C less A union B. And this is elements that are just in C. Okay, region 4 is the intersection of A and B less C. So region 4, A and B are joined together, and it's the intersection bit of it, taking away C. So it is A intersection C less B. You're noticing probably that I'm putting brackets around the 2 ones that I'm talking about the intersection before I do the less than. The reason you do this is to avoid confusion, that it's just the intersection of A and C less B. Because otherwise, if you didn't put in the brackets, it might be just C less B and people might get confused on that. But we're talking about the intersection, and that's why you need to put it in the brackets, just to explain that a little bit further. Now, in region 5, it's A on its own essentially, and it's taking out B and C together. So it's A less B union C. You're taking away B and C together, and again I'm putting brackets. So A only, or just elements just in A. Region 6, it's the intersection of B and C, taking out A. Okay, so it's the intersection of B intersection C less A. So you're lessing A from the intersection. Region 7 are just the elements in B when you take out A and C from it. Okay, so it's B less A union C. And these are the elements just in B. And finally, region 8 are elements that are not in any of those. So you're taking out A, B, and C together. So it's A, B, and C. You're taking them all out. It's complement. So A union B union C. And because I'm talking about all those things, I'm taking them all out. And that's what the complement comes in. And it's everything every set removed. Okay, and that's what that is. Okay, so this is just explaining the regions involved in the intersection of three sets. I'm now just going to show you it in practical application by doing example 1. I don't necessarily think I need to write it out for you because it is all written out here for you. So the universal set are the numbers between 1 and 12. A is the set 2, 4, 6, 8, 10. B is the set 3, 4, 5, and 6. C is the set 5, 6, 7, and 8. And you would have seen me there the other day how you actually start filling it in. You always fill in the intersection first. The intersection of all three. So region 1, let's say, the bit in the middle. And when you look at all of the numbers, I know that 6 is definitely in the middle for all of them. And then you start doing the process of elimination. So when you start going through the numbers and you see what the intersections are, okay, you can start filling in the Venn diagram. And then you'll realise that there's some numbers not accounted for and those numbers go on the outside. So the things are not in A, B, and C. And what I need you to get used to is actually just a notation on each of these. The intersections, the less thans, all those other different things. So I'm going to just explain this. The intersection of A, B, and C together is the bit in the middle, where the three Venn diagrams cross over, and that's region 1, and that number is 6, and you put it in chain brackets like as shown. Okay, the next one is the intersection of B and C together. So B and C, there's 2 numbers in that area, and that's 5 and 6. Again, put them in chain brackets. We're then asked for the intersection of A and B less C. Less C means take out C. So I'm just going to cover it first. And then you're going to look at the intersection of A and B together, and that number is 4 only. And the last one is B. So you want the numbers in B. When you take out the intersection of A, B, and C together, okay, so less A intersection B intersection C. So you want whatever's in B when you take out the intersection of all 3. So those numbers are 3, 4, and 5. Okay, and that's that question done. Okay, and we're just going to get used to using this notation from now on when there's more than 2 sets at play. Okay, it does take a little bit of getting used to. In some questions, you're asked to shade in the region, and you're actually asked to do that in question 6. In question 6, it's make 3 copies of the Venn diagram. So you have to draw this Venn diagram out 3 times, and you're going to shade in A less B. So you'll cover B, but you'll shade in this little bit. That's the first diagram. The second one is a universal set less A. So you'll cover that, but you'll shade in everything else around it and so on. So this is just getting used to you shading in the regions specified from a particular question. And it's just been getting used to intersection, less than, union. Sometimes you might have complement, cardinal number, those kind of things. So 2 pages ago, we looked at the commutative property, and that means the adding and multiplication stays the same for sets, whereas subtraction and division does not. The associative property is very similar. So earlier we looked at the commutative property where addition, it didn't matter if the numbers were switched the other way around, you still would have got the same answer. We're now going to look at associative, and associative is basically the multiplication of it, that it doesn't matter the order in which you multiply numbers. So it doesn't matter if you multiply A by B and then multiply it by C afterwards, or if you multiply B by C first and then multiply by A, you will still get the same answer. And again, addition and multiplication is associative, but division and subtraction are not associative. And it's just getting used to the fact that when you're adding things together or multiplying them, it doesn't matter what letter or number comes first. but it does with division and subtraction. And there's just some basic questions based on this. Afterwards, it's not anything too much to worry about. It's just stating the fact that addition and multiplication, it doesn't matter what order you put them in, but for multiplication and, for division and subtraction, it does. Based on the couple of things that we've looking at, so the union of the three sets and just the terminology associated with it, we're going to do a few questions. So far at this stage, you were doing questions 3 and 6, and I'm just going to give you the page numbers for that. So we're finished with our notes copy now. The notes copy was just using the three Venn diagrams. If you want to, you can say that multiplication and addition is associative and commutative. That means 4 plus 3 is equal to 3 plus 4. Likewise, 4 multiplied by 3 is equal to 3 multiplied by 4. Whereas division and subtraction are not. 4 minus 3 is not equal to 3 minus 4. Likewise, 4 divided by 3 is not equal to 3 divided by 4. Okay, it's showing that that relationship is applied to sets as well. We're finished with the notes copy. You're going to go to your normal maths copy now. And I'm just going to give you a list of the questions that are for today's class. So page 45, it's question 3. Page 46, it's question 6. You're then going to skip ahead to page 50. And we're going to do questions 1, 3, and 5. Okay, and that's it for today. You're going to join me live now, and I'll start into doing for the first couple of questions, and I might do one of the 3, but you'll have a couple just left for the last couple of minutes of class, and when you're finished, you're done. Okay, thanks a million, and I'll see you live.